Welcome to the third video of TensorBoard exploration. We'll look at how Graph Explorer helps us in visualizing our model graph. Graph Explorer is the main tool that we have in TensorBoard that will help us in visualizing our implemented graph. In this video, we'll look at how to visualize complicated models in TensorBoard and see if we have implemented our models correctly. We can look at how each of the nodes are connected to each other and if the connections are exactly what we expected, while implementing our network in code. We'll mostly be working with neural networks, and they get very complicated as you start dealing with complicated data. In order to see if we have implemented our model correctly and find potential bugs that are really not visible from code, we need some visualization components. Graph Explorer is going to help us here. It shows us all the information that we need to see if the connections made to each other are sensible, and if the network is actually going to learn from it. In TensorFlow, we have the ability to structure our model graph directly from our code, using scopes and variable names. Scopes help us have multiple graph nodes within a single expandable larger node, and inside, we'll have named graph nodes. It makes the graph visualization really easy to comprehend, as we will look shortly. In this code, we have two fully connected layers that are inside their scopes. Each of the computable nodes of TensorFlow has a name argument, which takes a string which is going to be its unique name in the graph. If you want to name two nodes with the same name, then they should be inside different scopes. Here we have a mapmul and a bias add node in each of the fully connected layers, and they are wrapped inside their corresponding scopes. Here's a sample view of a complicated graph using Graph Explorer. You could zoom in and out and expand different nodes here and see if everything is connected in the order as it should be. This is a basic AlexNet, and we'll talk about some minor graphical details here shortly. Here you could see the expanded as well as the unexpanded convolution layers in Graph Explorer. It really organizes our graph into modules. There are weights and biases tensors present in the convolution layers, and you could see how they are connected to each other here. Also, you could see the pooling nodes connecting the convolution layers. This is a simpler graph than before, but it is shown in greater detail. Each graph variable node is pointing towards a read node, which basically shows which operations are using this node. Here, the weights node is used by conv2d and histogram summary. Similar case is for the biases node. It also shows what operations we assign to it in the initialization state. Here, we have initialized the weights using a random distribution, and the blue truncated normal node shows this. On the top right side, you could see the details of the corresponding selected nodes and tensors. Here's an example of AlexNet model. We will now translate this into our Graph Explorer and see how it looks there. As you can see that this network is quite complicated, but Graph Explorer is doing well in breaking everything into comprehensible components, which makes the model debugging very easy. In this graph, the big gray boxes are what we get when we use our scope feature. As you can see, there are different color nodes contained in different gray scope boxes. The purple ones here are what we have our update variables into. The white graph nodes have the different compute operations, such as mapmul, bias_add, or sum, etc. The arrows show the flow of the graph, i.e., how the tensors are flowing from one node to the other. The dropout scope here contains all the necessary computations inside it, until it is given to the dropout node. If you haven't named a node, then it will be named by itself using the operation name such as mapmul_1, with a suffix number differentiating between different nodes of the same type. In this video, we learned about how Graph Explorer helps us in understanding the visual model of our classifier. No matter how complicated the model is, we could translate it into the Graph Explorer format and visualize it to find out the potential bugs and problems. Making a habit of using Graph Explorer in every model can help you be more productive and could even save you lots of hours of frustration. Next, we'll talk about how to change our previous not_mnist code to incorporate TensorBoard by showing where to put the merged summaries object, where to initialize the right object, and how to record the data into the log file at every required step. Feel free to play with the different sample examples that TensorFlow provides to play with its visualization tools.